everyone, I am Hafifa Alia and today I will talk to you about the solid-liquid separation and I will talk on the filtration part. Okay, before we start, I'm going to introduce you to the 4 terms that I'm going to use throughout the video. The first one is slurry. Slurry is a suspension to be filtered. Second one is the filter media, which is the porous medium to retain the solid. Third is the filter cake. Filter cake is basically the accumulated solid retained in the filter medium. And lastly is the filtrate, which is the clear liquid passing through the filter medium. In order to make you guys easy to understand, here I will do some demonstration to make it easy for you guys. This is a slurry, this is our filter medium, and this is the place where the filtrate will be stored. Okay, firstly, the feed will enter the filter medium and the filter medium will retain the large size of the particle on top. So this is how it works. The clear liquid already passed through the filter medium and the large particle will remain on top of the filter medium, which is called filter cake. That's it. There are a few things that need to be considered in order to carry out the filtration process. Firstly is a slurry. Slurry plays an important role in order to ensure the efficiency of the filtration process. The higher the viscosity of the slurry, the lower the rate of filtration will be. Next, the pore size of the filter medium. As we can see from here, the filter medium has a specific pore size. The larger the pore size, the less efficiency will be, as the whole of the pore size will allow more particles to go through it. Pressure drop from feed to the filter medium and the gravity force also are the factors that need to be taken into the consideration as well. Okay, we are done with the filtration part. But then, I think we still got a lot more of the solid liquid separation process and method. So, let me show you what my friends got for it.
For settling and sedimentation, the mechanism used is actually separations of a dilute slurry of suspension by gravity settling into a clear fluid. There are 4 settling types, which are discrete or free settling, Foucault settling, hindered settling, and compression. Free settling is when the fall of a particle is not affected by the boundaries of the container or from the other particles. This is due to a sufficient distance between the particle container and particle-particle. Hindered settling is when the fall is impeded by other particles because the particles are near to another. At the start, all particles settled by free settling in suspension zone B. The particles zone B settle at a uniform rate at the start, and a clear liquid zone A appears. The height of Z drops at a constant rate. Zone D also begins to appear, which contains the settled particles at the bottom. And Zone C is a transition layer whose solid content varies from that in Zone B to that in Zone D. After further settling, Zone B and C disappear. Then compression first appears. This moment is called the critical point. During compression, liquid is expelled upward from Zone D and the thickness of Zone D decreases. The particles can be solid particles or liquid drops, while the fluid can be a liquid or gas and either static or in motion. According to Stokes' law, when a particle with mass m passes through a fluid, it will experience gravitational force, buoyant force, and drag force. Gravitational force acting downwards, buoyant force acting upwards, while drag force is acting opposite the motions of particle. The terminal velocity of a falling object is the velocity of the object when the sum of the drag force, Fd, and buoyant force equals to the downward force of gravity, Fg, acting on the object. Since the net force on the object is zero, the object has zero acceleration. The example of equipments are settling and sedimentation tank, speed constant gravity settling classifier, and continuous thickener. I'm CG and thank you for watching my video. Please don't forget to like and subscribe.
Centrifugation by Siti Fatimah. Centrifugation is a process of separating substances of different densities from a mixture by using centrifuge. Centrifugation works using sedimentation principle, Stokes' law, but is accelerated by centrifugal acceleration. This is how centrifugation works. Samples rotate around a fixed axis, which makes the sample spin in circles. There are two types of centrifuge, which are industrial centrifuge and lab centrifuge. Both types have the same forces developed in centrifugal separation, which is centrifugal force. Let the circle be the spinning motion of samples. Perpendicular to the axis of spin, there is centrifugal force facing outward, which is equals to m omega square r, where omega is the angular velocity of particle. Since v, which is tangential velocity of particle, is equals to r omega, then the centrifugal force can be further into mv square over r. From this diagram, we can see that substances experience centrifugal force away from the center, which forces the materials against the wall of the tube. Then, components mixture get separated because denser particle falls to bottom, while lighter to the top. Rotational speed, revolution per minute, is omega equals to 2 pi n over 60 and then rearranged to n equals to 60 v over 2 pi r, where n is the rotational speed. Then the centrifugal force is further into 0.011 mrn square using the rotational speed equation. The centrifugal force is often expressed as equivalent to g forces. According to the centrifugal force equation, the amount of centrifugal force depends on its mass and speed of rotation. With an increase in speed of rotation, even lighter material can settle down. An example of solid-liquid centrifugal separation is this-wall centrifuge. It is used in starch-gluten separation and cream separation.
Hi, I'm Amira and I will explain about mechanical expression. Mechanical expression is one of the ways to extract oil and juice from plant materials. How does it work? The raw materials are squeezed under high pressure in a single step. Mechanical expression alone does not remove all of the oil from the seed. Hence, the process will be followed by chemical extraction that uses solvent to remove the remaining oil that mechanical expression cannot. Mechanical expression can be done by batch using hydraulic press or continuous process by using screw press. Firstly, mechanical expression using screw press. The raw material will enter from seed hopper and waste product will exit to the other side. The screw press uses friction and continuous pressure from the screw drive to move and compress the seed material. The oil seeps through small oil canals that do not allow seed fiber solids to pass. Afterward, the pressed seed are formed into hardened cake, which is removed from the machine. Next, mechanical expression using hydraulic press. Hydraulic press uses liquid as working medium to transfer energy based on Pascal's principle. The oil seed is fed in the chamber and pushed upward by the force in the hydro cylinder. The oil flows down to the oil tank through the drip tray. Throughout the process, the temperature needs to be constant so that the organic ingredients in the oil plants will not be destroyed. This method is suitable for plants with high oil content and must be processed with cold processing.
Membrane Separation Techniques by Lo Yin. There are three main membrane separation techniques. The first one is reverse osmosis (RO). Second one, ultrafiltration (UF), and the third one is microfiltration (MF). Let's look at the first membrane technique, reverse osmosis. In reverse osmosis, its pore size is 10 to the power of -4 to 10 to the power of -3 micrometer. The anion and cation is repulsed due to the formation of pure monowater layer over the membrane, so only water can pass through the porous membrane. Reverse osmosis technique is used in converting filtered water to purified water because reverse osmosis membrane is able to remove chemical and organic or inorganic contaminants, which are ions, bacteria, pesticides, viruses, and dissolved solids such as lead, cadmium, and mercury. For the second membrane separation technique is the ultrafiltration. In ultrafiltration, the pore size is 10 to the power of -2 to 10 to the power of -1 micrometer. Both anion and cation can pass through the pores. This is different with the reverse osmosis. And large particles will be retained, such as a protein, but the smaller ones will be permeated. Ultrafiltration has a sharply defined molecular weight cutoff, MWCO. It will retain all particles which is larger than MWCO and will allow smaller ones to be permeated. The larger one will be protein, polysaccharides, bacteria, and others. Ultrafiltration can be applied in food products such as apple juice. Ultrafiltration can prevent the enzyme activities which will cause browning. The third membrane separation technique is microfiltration, MF. In microfiltration, its pore size is 10 to the power of -1 to 10 to the power of 1 micrometer. If compared with ultrafiltration, protein and polysaccharide are permeated in microfiltration. Microfiltration is important in whey processing, where it will reduce the total number of lactic acid bacteria and other microorganisms in whey. It is also responsible in defatting, at which the fat content is removed in the final product. Thank you, and that's all for membrane separation.
Okay, that's all for the solid liquid separation. I hope you have a better understanding on what it is. So till next time, bye bye.